going to begin with a 1s orbital, and I have to actually tell it to go, so auto. So if you look over here at this picture, so this is our 1s orbital. What you're going to start to see as we let that electron move all around is you're going to end up with a spherical kind of a shape. That's one, at most 2 electrons, but let's just say that we're talking about 1 electron in that space. And then let's see what happens if we put a 2s orbital on top of it. Now remember the last one was red. You see our red one? Do you see how small our red s is compared to our red 1s is to our 2s? Now let's go ahead and we'll put another s on top of it. Let's put our 3s on top of it. So our 3s, see how the outer red is the 3s, the inner green is the 2s, and then the inside red is the 1s. You see how they're all spherical? They also don't, they all have like, especially if you zoom in, they have like this little area. They don't cross over into each other. But that's the shape you will find the electron in. And those electrons that look like they're blipping around, it has the same energy the whole time. It's not like losing speed or gaining, like it's a consistent speed right there. And then let's see what happens when we layer in some p orbitals. So I'm going to restart it and just start with our 1s, our 2s, and our 2p orbitals. So you can see here, there's a 2p orbital. You see how like we have a left and a right side? I'm going to put in a px, a py. So here's our py. Do you see how that's the same? It's just in a different direction. And then our pz. Again, get that pz going. Oh, py, pz. Oops, let me restart it. It didn't want me to do all those layers of it. All right, so we have our 3pz. Oh, I'm in the wrong plane of it. I've got to rotate it. Oh, it won't let me rotate it on this. If you were doing this on your own, you can rotate it. And let's just see the difference if you put like a 2px and a 3px on top of it. So look, the outer, you can see the big red and the big green, that's the 3px. And inside, the little red and little green is the 2px. I'm hoping this is emphasizing how these are increasingly larger orbitals of the same-ish shape. There's one more that's also really, really nice to look at. And it's this wave-like one. This emphasizes the idea of it being a wave, which is really, really nice also. Let me go ahead and put it back to our s orbital, and we're going to have one there. So if you watch this for a minute, you could probably get yourself to fall asleep after a while. They will start to change colors and stuff. So that is our first s energy level. Let's give it a second. So the inside one is your first S, and the outside is your second S. Now we have 3. See how much larger the third one is than the second, than the first? Let me go out to 4. You see all these different levels. So the outside dark green, the outside green is the fourth, and then the bluish right now, it's changing colors, third, second, and then first. And then I can also do P. So hold on, let me go back. I don't have any P in the first energy level. Second energy level, I'm going to give it a P. So look, there's those P's. And I'm going to do the third energy level of P's. So see how they get larger and larger? But I like this because this feels more wave-like. Electrons are kind of like waving in and out, kind of. So now you have a sense for how we try to go about drawing these orbits, and then you can see why we might choose to use the Bohr model to represent information, because it's much easier than all of these levels of electron regions. There are these little spaces where they don't cross over into each other, and those are called nodes. So anywhere there's like a dark space, the electrons aren't crossing into each other's space. I'm actually turning it sideways right now. And those are called nodes.